Now we will see how queues work. There are two functions, NQ and DQ. NQ means from the rear we insert the data from the front and remove the data from the rear. NQ and DQ. DQ means remove, NQ means add. Okay, now let's start. Void NQ. Void NQ, and we have node pointer to N1 and node pointer to N2, and we have integer number. Okay, in the NQ we have a node of node temp pointer to temp, and we allocate the memory. Temp is equal to new node, and we have temp data part is equal to number. Temp data part is number, and we have temp link part is null. Okay, we NQ the data. If pointer to N1 is equal to null, if N1 is null, then pointer to N1 is equal to temp. Okay, else pointer to this is N2, right? Pointer to N2, node N2, pointer to N2 is N2 of link is equal to 10. Okay, and we should have pointer to N2 N2 is equal to 10. Okay, so in the else part we have this, in the if part this is NQ. Okay, so we have a display function. Display function is simple. Void display node pointer to N1, then we have while loop, N1 is not equal to null, do until N1 is not equal to null. Cout if N1 link part is equal to null. If it is null, then Cout it is rear of the queue. Okay, and Cout handle N1 data, and we have N1 is equal to N1 link part. Okay, so next node will be there, and we have while loop, and we print the data. Now let's call the NQ function, and we will have two variables. Node from the front and from the rear. Okay, two variables. We have front is equal to rear is equal to null. Okay, so initially front and rear both point to null pointer, right? And we call pointer to n1, and n1 of nq is and front, pass, and rear, and 10. We have n1 and we nq another. This is push function of this, right? So front is front, right? So this is and front and rear, and we have 20, and we should display the data, display n1. Okay, now let's see. So we have temp link. Okay, temp link. We have front. This is front. This is rear. We have this address. Close the program. Temp is equal to new node. We have temp is equal to new node, temp dot data is number, temp dot data is number, temp dot link is null, and if pointer to n1 is equal to null, then n1 is equal to should be temp. Okay, and else part n2 should be n2 link part should be temp. And pointer to n2 is 10. Now we have in the while loop, we have n1 is not equal to null, then n1 link, if n1 link is equal to null, then print this, and n1 dot data, n1 dot link is equal to n1. So there is no problem. With the structure. This is NQ function. n1 is equal to 10 and else n2 dot link is equal to 10 and n2 is equal to 10. This is okay. There is no problem. Temp dot, so temp is here, temp dot link is null, temp dot data is null, this is equal to this, else this, so n1 is not equal to more than 1, then we have front here is equal to there is no problem at all. In the list there is no problem. Front and rear is equal to null, and we should have this. N1 is this, NQ, N1. So display should have N1 data. It is a number, new node, data is number, link is null. If n1 is null, n1 is null, pointer to n1 is null, then n1 is equal to 10, else n2 of link is this, and we have temp is equal to this. There is no problem. Then we have this is equal to null, n1 dot display function. We have n1 data, we have n1 link, so n1 and n2 is node, number, new node, n1 link part, temp link is this, we have node link. So there is no problem. What is the problem? Why it is not showing something? Let's compile it again. It is 15. Close the program. We should add okay, so we have N1 here. We should display and front. Okay, so we should display and front. No matching function call to node display. We should pass, okay, this is not double pointer, we should pass the address, right? So this is how you learn, right? Okay, 10, that should be top. Okay, there should be some of the front. We should display the front, right? And rear is 20. We should display it like this. We should display Cout and front. Okay, Cout front. Now if you display it, okay, front is 10 and front rear again. This should not be inside while, right? This should be outside while. Cout front. Okay, now we have DQ, void DQ, and we have node pointer to N1 and node pointer to N2, and we have DQ means pop. Okay, so node 10, we have integer data, integer D. Okay, and if pointer to N1 is equal to null, Cout no item found, else temp is equal to pointer N1, D is equal to temp data part. This which will fetch and return the data. Okay, and we have pointer to N1 is equal to temp link. Okay, and we have to free the temp. Free the temp if pointer to N1 is equal to null, then pointer to N2 is equal to null. Okay, so we pop from the back of the queue, from the other end, rear of the queue. Okay, and we should return D, and D should be, D is here, right? This is DQ. Now we add another, add N1 and NQ and front and rear and 30, and we DQ N1, DQ, DQ. So DQ from the rear. Okay, so DQ has front and rear. DQ means we should have front and rear. Okay, these are the 2 pointers, and we should N1 the display. Display, this is display means now we will display we should print the value of N1. See out, this is integer D. Integer D is equal to this, and removed item is D. Okay, removed item is D. Now we display N1 dot display front. Okay, N1 dot display. Okay, now we compile this. Okay, there is problem with temp. Temp is basically a pointer, and we have another error here. And rain, right? Return D. Return statement with, okay, value. Right, now we have this integer. It will return an integer. So we have front 10, rear 20, rear 30, and removed item is 10, front is 20, rear is 30. So this is some kind of, in the display function we should have new line, right? New line. We should have new line. Now we will see. Front is 10, 20, and rear is 30. Removed item is 10, removed item is 10, and now front is 20 and rear is 30. Okay, so we should have this new line. Here we should have new line, and so front is 10, 20, rear is 30, removed item is 10, front is 20 and rear is 30. Okay, so 10 has been removed from the front. Okay, so So this is how we use queue data structure, right? So we will use threaded binary tree, and in the binary trees, next is binary trees and threaded binary trees, and we will have also in the pointer section we will have some hardware interaction, right? How hardware is used, how graphics is used, how video memory is used, right? We will see that.